This video is about using Cockroach and Dendro in the Grasshopper environment to turn point clouds into boundary representations, specifically tri-meshes, in this case for tree canopy. So these point clouds, these white point clouds here, are already segmented into connected components using Cloud Compare. And in this script, there are two plugins, two Grasshopper sets of components, primarily in use, one being Cockroach, which is just for manipulating point clouds, and then the other being Dendro, which does volume modeling using the OpenVDB libraries. So here I've selected one of these point clouds, and I'm using downsample and then a statistical outlier filter, so you can see the magenta ones are the ones that are the output of the component that I've selected, and the white ones are ones that were excluded. And then clustering, so in some cases resulting in more than one cluster. And then actually exploding those into the individual constituent points, and getting rid of any resulting point collections which are below the minimum that I'm setting here, 50 points, and then using those point collections. In this case, there are 2 point collections lists. The larger one has about 1,600 points in it, and then feeding those into this component, Dendro component, to convert them into a volume, data type volume, and then using smooth component, still Dendro, which has a width and smoothing type Gaussian, Laplacian, mean or median. And this is all just done by kind of trial and error. Then there's an offset. The offset is, in this case, a positive offset of 1.5 units, here in feet, and then immediately another offset, a negative offset of 1. So basically, the result of the point volume is this sort of blob, but that's more crenulation than I really need or care for. So I smooth it, and then in this case, it's not really necessary to do these kind of gymnastics, but in some of the other ones, basically I make it bigger, and then let's see, seems to be offsetting it twice. Okay, so I'm making it bigger both times. I don't know why that's the case. But the idea being that by offsetting it, it sort of absorbs any smaller like crevices or little holes or notches get absorbed when you make it a little bit bigger, and then you can make it a little bit smaller as a way of sort of gaining that coalescing dynamic. Then volume to mesh is the next function here, and basically it just takes the special Dendro volume data type in and a collection of settings and turns it into a mesh. And unfortunately, a lot of the time that mesh is not a good mesh. So the volume settings here are the voxel size for the resolution, bandwidth, which, let's see, desired radius in voxel units around the surface. ISO value, adaptivity. So this is kind of the open VDB magic that I don't really understand. That's where you're finding the boundary and turning it into a mesh. Then okay, we got to turn on display mesh edges. Okay. So the mesh looks like that. And then this mesh repair actually comes from, I believe, Cockroach again. Cockroach has a mesh repair component, which I don't really know what it does, but sometimes it helps. And then clean just gets rid of any bad meshes, just throws them away. And so this is the resulting mesh. And then tri-mesh is actually a Grasshopper native component, and it's worth looking into just all by itself. It's a good it's a very well developed triangle remeshing algorithm that's been around for a while. And here I'm just feeding it basically the mesh that came out of Dendro and a target edge length, and the result is pretty clean. So let's compare this to this substantially larger, but I don't really see that as being a problem because I would rather have the cells, basically the sample points, the grid cell locations of my fluid dynamics model, rather have them false positives than false negatives. So having it be a little bit bigger is fine with me. And there's also kind of an attrition of points, like all of the processing of trying to get these tree points, you're losing a lot of tree points. So I sort of assume that the canopy and the area of influence of the canopy is probably bigger than just this. So, but I'm sure that there's plenty of refinement that could be done, to make it more accurate. So that for these canopy point clouds of this size, it's pretty effective. It goes pretty nicely, but it requires functions from 3 different libraries. I mean, from standard, Grasshopper stuff, but then from the tri-mesh, which is kind of its own animal, and then Cockroach and Dendro. So that's the workflow. That's the pipeline.